In this video, I will demonstrate how to solve the exercise presented in the flexible manufacturing system slides. The question read, a flexible manufacturing cell consists of two machining workstations plus a load-unload station. The load-unload station is station 1. Station 2 performs milling operations and consists of one server, or one worker using one CNC milling machine. Station 3 has one server. Again, this is a worker that performs drilling using one CNC drill press. The three stations are connected by a part handling system that has one work carrier or a worker. The mean transport time is 2.5 minutes. The FMC produces three parts A, B and C. The part mix fractions and process routing for the three parts are presented in the table below. So in the table there are different descriptions. The first column is the part mix fraction, part label A, B, C. Then we have the second column is part mix, fraction 0.2, 0.5, 0.3 and 0.5. And this is the sequence of operation 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And the description, load, mill, drill, unload. And the corresponding station. So load is performed at station 1, milling performed at station 2, drilling performed at station 3. And the last column presenting the process time. The operation frequency F equal to 1 for all operations. Determine A, maximum production rate of the FMC, B, corresponding production rates of each product, C, utilization of each machine in the system, and D, number of busy servers at each station. So before we proceed, we need to identify the parameters presented in the questions. So there are three parts, labeled as A, B and C, and the part ratios, the summation of the fraction A plus B plus C equals to 0.2 plus 0.3 plus 0.5 equals to 1. So in any question, the part ratio, the summation of the part ratio will equal to 1. Whether it is 2 products or 3 products or 4 products, the summation will be 1. Then there are 3 stations. One is for load and unload. Station 2 for milling operation. Station 3 for drilling operation. Number of workers at stations. Station 1 has 1 worker. Station 2 has 1 worker. Station 3 has 1 worker. In the text, they use the word server. Workers at part handling system is 1. And then we can start to solve the problems. So in any question, for this type of system, you need to identify what are the number of parts, the part ratio, the station involved, and the number of workers. So the first one, we need to find maximum production rate of the FMC. So in order to find the maximum production rate of FMC, we need to calculate the workload for each station. Right now we have identified 3, for load and unload, for milling station, and third one is drilling station, and there is another one we call as the workload at the part handling system. So even though there are 3 sessions, but from the text we know that there is another process, important process called as part handling system. So this one will become WL4, workload at part handling system, or WL4. Okay, the calculation for workload equals to, okay, the process time at that station, the operation frequency times the part ratio. Okay, then we have to add with the corresponding process time and the operation frequency times part ratio for the second part. Okay, now is part B, and then we have to add the process time, okay, involved for part C. Okay, so this formula will be repeated, okay, for each of the products. So this is product A, then we have product B, and we have product C. Okay, to solve the problem, we have to calculate the workload at each of the stations. Okay. So for example, for workload at station 1, there are two processes, load and unload, and the processing time is 3 minutes for loading and 2 minutes for unloading. So the question use 3 plus 2, okay, for the two processes, and the part fraction 0.2 for part A, and the operation frequency 1, plus, okay, the process time involved for the part B. So again, load 3 minutes, unload is 2 minutes, okay, 3 plus 2, times the part fraction, which is 0.3 for part B, okay, and the operation frequency 1, plus the process time for the part C. So again, load is 3 minutes, unload is 2 minutes, times 0.5 part mix fraction, okay, for part C, and 1.0 for the operation frequency. Solving for the equation, you will get 5 minutes. Another example for to calculate the workload at station 2. Okay, so the process time for milling operation, okay, at station 2 for part A is 20 minutes, okay, and the part fraction is 0.2 for part A, and the operation frequency is 1, plus the process time for part B, okay, so milling process 15 minutes, okay, and the part fraction for part B is 0.3, and the operation frequency is 1, plus the process time for part C. So part C, okay, for station 2 milling operation, the process time is 22 times the part fraction 0.5 for C times the operation frequency is 1. Okay, solving for these equations, we will get 19.5 minutes. And the workload at session 3, the process time for drilling is 12 for part A. So drilling session 3, 12 minutes. Okay, and the part fraction is 0.2 times the operation frequency, which is 1, plus the process time for part B, which is drilling at station 3 is 30 minutes, times 0.3 for part mix fraction for part B, okay, 0.3 times operation frequency, which is 1, plus the process time for part C, okay, here part C for drilling operation at station 3 is 14 minutes, times the part mix fraction 0.5 times operation frequency, which is 1. And solving for these equations, we'll got 18.4 minutes. Okay. To calculate the workload for part handling system, okay, so this one we refer as workload at station 4. The formula is NT times T. So time T is given in the question, which is transport time is 2.5 minutes. Okay, now we have to solve for NT, number of transport. So the easiest way to calculate for NT, we can look at the route, okay, of the paths. So the path will go through station 1 to station 3, from station 1 to station 2, then you will go to the station 3, then lastly you will go to station 1 for unload. Okay, so 1 is loading, 2 is milling, 3 is drilling, and the last one is unloading. So the number of movement is 3. Okay, 1, 2, 3. Okay, so you can count the arrows. Okay, and this technique is valid for operation frequency equal to 1. Okay, in this case is valid. So this is the easiest way to find what is NT, number of transport. So NT is 3 multiplied with the transport time 2.5 minutes. So the workload at this station WL4 is 7.5 minutes. This is the answer, 7.5 minutes. Okay, so the next step is we need to find the bottleneck station, okay, the one with the largest WL per S ratio. Okay, WL the workload per server ratio. So we have calculated the workload. Okay, so session 1 is 5 minutes, session 2 is 19.5 minutes, session 3 is 18.4 minutes, and session 4 is 7.5 minutes. And these values need to be divided by number of server. Okay, S is server, which is also worker. Okay, so again we can go back to this information. So workers at session, okay, workers at session 1 is 1 worker, worker at session 2 is 1, worker at session 3 is 1, worker at part handling system is 1. Okay, so basically all this value will be divided by 1. Then we will get the numbers. Okay, 5 minutes, 19.5, 18.4, 7.5, and the largest ratio is considered as the bottleneck to the system. Okay, so the bottleneck is station 2. Okay, and from there we can determine the maximum production rate of the FMC. Okay, so basically 1 divided by 19.5 minutes, okay, equal to 0.05128 pieces per minute, and this one can be converted into hour, okay, by multiply by 60, so we get 3.077 pieces per hour. So this is the maximum production rate of the FMC. So for this one, the formula is Rp star equals to 1 over 19.5. So what is 1? So basically Rp by formula is S over WL. Okay, so S for workstation 2 is 1. Okay, 1 worker, that's why this is 1. Okay, so this is 1 because of 1 worker divided by the workload. Okay, 19.5. so basically it's a reverse from this ratio. So Rp equals to S over workload. Okay, so for solving this one you get about 3 pieces per hour. The second question is to determine the corresponding production rates of each product. Okay, by referring to the bottleneck station, we will use this value 0.05128, okay, as our reference, and multiply this value with the part mix fractions. Okay, so the production rate for part A is 0.05128 times the part fraction for A is 0.2. Production rates for part B is 0.05128 times 0.3, which is part fraction for part B, and production rate of part C is 0.05128 times 0.5. Okay, the part fraction for part C. So multiply these values, okay, you will get pieces in minutes, and then you have to convert into hour. So you got production rate for part A is 0.6154 pieces per hour, part B is 0.9231 pieces per hour, and part C is 1.5385 pieces per hour. Therefore, it is very important to identify the correct bottleneck station. Okay, so again, bottleneck station is the one with the largest WL/S ratio. Okay, in this case is station 2. Okay, and if you add these three production rates, okay, 0.6, 0.9 and 1.5, the total of this production rate will equals to this value 3.077. Question C is to determine the utilization of each machine in the systems. So the formula is the ratio, okay, WL/S times the bottleneck production. So for station 1, WL/S is 5/1, okay, times the bottleneck production 0.5128. Session 2, 19.5/1, times 0.05128. The session 3, 18.4 divided by 1 times 0.05128, and the last one 7.5 divided by 1 times 0.05128. Again, over 1 is the number of worker, so since number of worker for all stations are 1, okay, and then 0.05 again is the bottleneck production rate. Okay, so solving for these equations, you will get the percentage of utilization for each machines, and you will see that the utilization at session 2 is 100%, means that it is at the maximum production. Okay, for the last question, determine the number of busy servers at each session. So determine the number of busy worker at each session. So busy server, okay, at session 1, the formula is the workload times the production rate, the bottleneck production. Okay, so 5 minutes times the bottleneck production. So 5 times 0.05128, you got 0.256 servers, and continue for the using the same formula for each stations, session 2, 3 and 4, you will get the number of busy servers. Okay, at session 1, session 2 is 1.0 server, session 3 0.944 servers, and session 4 0.385 servers. That's all for this tutorial, how to solve this exercise. So I hope that you can try out by yourself, okay, how to solve the exercise without referring to the solutions. So thank you very much.